Let's get started with the second session for the day. So I'm going to start first. Hopefully the other participants will join in. I think Matthew will be on after me. I'll keep this short because I want to try and keep it to time. Some of this has been covered in previous sessions. You can look back on the recordings that I would have done around smart legal contracts at the various different CBC meetings, and some of the questions that were addressed and some of the topics that were addressed in the session before this by Gavin and others around the legality of smart legal contracts is an interesting session, and we've covered this on previous sessions as well, so I won't go over that too much. So in this particular session, I'm going to show you an example of bringing two different technologies together, both of which have been discussed just prior to this session and many times in the past as well, around agentic AI and smart legal contracts, and with a specific example of how we could use that for implementing a JCT-based milestone payment implementation. So a little bit about myself. I've spoken at this a number of times before, so I'll keep it brief. A few different hats on, to say the least. Member of the CBC from early days, and also the CBT at UCL. I'm a lecturer at the School of Management, teaching computer science as well in the area of AI, blockchain, and entrepreneurship. I've founded a number of companies. One is called The Building Blocks, which is a venture studio in the area of AI and blockchain. Also co-founder of Deepflow, which I'll talk a little bit more about in a moment, and part of a few open source initiatives, various different blockchain projects such as Hedera, and very much active in the Accord project, which is one approach for developing smart legal contracts. Not a lawyer. There were plenty of lawyers talking before me, but I worked around legal industry for a number of years as well. When I worked at Mishcon de Reya, in particular, around some land registry and construction projects as well in the blockchain space. We founded a company called Regular Tech as well, which I'll talk about, which is building smart legal contracts for some of the topics we're looking at. There was quite a lot of talk about tokenization earlier. At the Building Blocks, we tokenize a number of different asset classes. In the media space, it's songs and movies, working in financial services as well around tokenization of different assets. So Gavin gave a very good overview of the state of the world there. Things are moving closer to regulatory certainty, I think, and the way that financial institutions will embrace tokenization in a regulatory compliant way. We've done a lot of work in and around the topic I'm talking about in the past, in around oracles, which I spoke about before, smart legal contracts, particularly in the area of real estate and finance to a lesser extent, but also in construction. There were some examples given earlier today around the land registry proofs of concept around the world. I spoke to that Swedish team, actually, that was mentioned earlier when we were working with the land registry in the UK, which did its own proposal for implementing decentralized conveyancing quite a number of years ago. Wrote a paper about that is linked here as well, that people can have a look at. But it was still very early days and hasn't really happened. So it's good to see something happening in areas like Dubai. This is really in two parts, one around AI and AI agents, and the other about smart legal contracts. So I'll start with AI because that's the big topic of the day. Obviously, there's a number of opportunities for AI in the construction sector. I'm not going to go through all of these. It's been covered many times in the past, and there's a few talks on it coming up. But I think we all realize there's a huge potential for AI, but for good, but for not so good necessarily, depending on where you're sitting and what your interest is in this space. But nevertheless, there's a huge number of opportunities. I'm going to talk about one way that we can help to bring the AI and the contracting piece closer together. In particular, looking at, in the UK at least, JCT, NEC contracts, and to a lesser extent, fitted contracts as well. Obviously, we're not saying we can implement all of these contracts in AI. We can implement all of these contracts in smart contracts, which was mentioned earlier, a number of real world issues that we've addressed many different times in many different CBC conferences for all of the good reasons that were analyzed earlier. Privacy being one of them. I'll come back to that, and some of the improvements that have been made in that space. We have seen quite a number of different initiatives in AI powered tools and construction. Again, not going to go into all of this. There's quite a number of different areas. This is by no means probably up to date in many ways as well. There's quite a lot going on in that space. We'll talk a little bit about the challenges, though. Some of these were mentioned earlier and likely to come up in later talks today. And that's we have some practical problems in implementing AI, not least resistance for people to adopt AI and worried about taking jobs, etc. We have major issues around data quality. It's fine in a training environment. It doesn't necessarily translate to real world implementation on a building site and all of the challenges that go with that. There's huge liability issues, as the lawyers can definitely attest to, and they're probably rubbing their hands in the event of disputes and who gets sued in the event of a problem, etc. We're in early days of certification of AI, and recognizing that there are some initiatives and some decentralized identifiers and reputation scores and various things that I've seen. But it's very, very early days, and there's a lack of regulatory certainty. There have been some guidelines. In fact, the EU are, I was told yesterday, sort of dampening down some of their recommendations around AI and some of the ways they wanted that enforced. Some people are saying it's as a result of pressure from the bigger tech companies in the US. It remains to be seen, but definitely we need some more clarity on what can and can't be done with AI. Massive concerns around data privacy and leakage of data into models, and private AI versus third-party services like OpenAI, etc. Huge problems with accuracy, hallucinations, guardrails, etc., and many other things that need to be addressed. So it's not all plain sailing by any means with AI. We need a way to manage to get the good parts of AI while still having humans involved, I think is the key thing here. It's not going to completely take over anytime soon. So for all kinds of reasons, we still need humans, mostly around regulatory and compliance concerns as well. But we genuinely do need humans involved in order to make sure that the AI is doing what it's supposed to be doing, and making sure it's not going off and hallucinating or making wrong decisions and signing off things that it's not supposed to be doing. So I think we're all aware of some of these issues. Anybody who has used AI even to not even to a great extent will see the limitations of where it tends to go wrong. So we need to not completely not use AI, because I don't think that's realistic. It's a question of how do we use it and get the most out of it while not completely relying on it and having bad consequences down the line. So I think the way that the industry will be going is that AI may assess the situation, but it really depends on the human to approve, and in many cases go back and tell the AI, give it some feedback. No, you're wrong because of X, Y, and Z, or did you think of this? And then continuously, hopefully, improve AI, ideally through reinforcement learning. And then finally, once the human is approved and happy with the work, then we have a contractual system of record that maintains that audit trail. What did the human say? What did the AI agent say? And having that audit trail for dispute resolution, for reporting to auditors, and more, well, basically better operation of the system. So if one thing gets signed off, somebody else gets paid, for example. One way that we're looking at doing that is a little company that we formed called Deepflow, but myself and a previous contributor to the CBC for many years as well, Dr. Alistair Moore, is also a lecturer at UCL. We helped with others to co-found Deepflow a number of years ago, and that's looking at human and AI orchestration at scale. How do we have teams of humans delegating to teams of agents? And how do we, in many cases, have teams of agents that may delegate back to the humans? And looking at not a full AI flow, but how do we have the best of both worlds with humans and AI working together? In order to do that, we have to deal with multi-agent workflows, which is quite a challenging area. This is a picture from a paper that one of our colleagues, Charlie, and others put together, which was actually presented at a conference over the weekend, looking at multi-agent workflows and how do we have a manager agent that can delegate effectively. Why? Because workflows get complex very fast. These are some screenshots from the Deepflow platform where we try and break down these tasks into flows. Won't get into all of this. If anybody's interested, this conference is going on at the moment, and the team have been presenting their work, and the paper is available and already been cited by some researchers from Stanford and others. Last year, I spoke about verifiable confidential computation, so I won't go into that. But there was a lot of talk about smart contracts not being suitable for certain types of workload. That is very true. However, I would say that there has been a shift in the last number of years, even in the last few days. Even the Ethereum ecosystem is moving more towards privacy-focused smart contracts. I gave a list last year of a number of different initiatives, chains like Midnight, for example, which are launching next year, which are trying to combine private smart contracts with public data and allowing for selective disclosure about certain aspects. So showing just enough to the public or to regulators or to clients. I think things have moved forwards in a way that things that were not possible with smart contracts due to the public nature of them are actually becoming more achievable over the next few years. So definitely, I think there's been huge steps forwards in this space. For construction, these were some of the use cases I identified last year around private smart legal contracts for agreements, which is what I'm going to demonstrate now, and the use of zero knowledge machine learning and zero knowledge compute in general to prove that something has happened. So we can have private agreements using these technologies. We've built an implementation that can help to have the legal contract, or part of it at least, execute, and then gather the audit trail and presume that it will not be completely covering all of the potential possibilities and all of the things that could happen outside of the realm of the contract, but gathering data for dispute resolution. And then if that dispute is resolved, allowing the contract to move on from the resolved state so it can continue to execute. So was some talk about smart legal contracts earlier and the legal standing of them. I'm not going to go through all of this again. It's covered in many other talks in the past, but there is some certainty depending on the jurisdiction you're in. The Smart Legal Contracts Initiative Smarter Contracts Initiative from the LawTech UK and the UK Joint Task Force in this space have given some certainty to government around smart legal contracts and smart contracts. So you can look it up. It's all there and public and has been since 2019. Want to show a practical example. This is something that involves the JCT contract, which is what I'm here to talk about. And that's where you can use, in this case, I'm using the Accord project's way of referring to contracts and templates and data models. It's where we can have a JCT extract, not the full contract, but a starting point at least, where I think we can use this as a basis for implementing some of the complexity of a JCT contract or later an NEC contract if people are willing to work with me on that who are closer to these contracts. So I think we can use these contracts and we can interact with them via AI, because in the last year, around about this time last year, this was only sort of new technology, this concept of model context protocol. This is how your AI agents or your tools like Claude or OpenAI, whatever tool you fancy, can actually speak to the outside world. So we've developed, as part of the Accord project and later in Regular Tech, the company I'm building under the building blocks, a way for AI agents to speak to contracts via this MCP service that I mentioned. So it's a way for AI agents to break out to the outside world. And this is a standard way that many companies who build AI agents are allowing these agents to speak to tools to speak to the outside world. So we've already solved that problem effectively of how can a contract be interrogated by an AI agent, and you can ask questions that will look up the contract, retrieve certain details. And in the case of what we do in the Accord project, you can actually go and trigger clauses as well. So it's not just reading the PDF, it goes far beyond that. It's really far more powerful than just reading the text of an agreement. We've done some work in AI around drafting smart legal contracts as well. Mentioned in the past, there's a paper on that, and I helped to move this work forward in the Accord project via the NLP working group. So here's a quick screenshot. I don't have time to do the demo in the interest of time today. I have a recording of this on a previous talk I gave quite recently in the blockchain community that I can share with anybody. But this is an example of our own tool in Regular Tech for generating a simple milestone-based payment schedule that would satisfy something similar to the JCT agreement. So if a certain milestone happens, then payment will be released, or at least it could be released on chain. There was a lot of talk of that earlier around tokens moving. In reality, what this does is it triggers a workflow and deep flow where somebody can go and execute the payment off chain. Because that realistically, that's where most of the payments are at the moment. But in the future, it could totally be an on-chain release as well. So we've represented this using the Accord project. We can go through the well, this is the main bit of the contract, really. It's around, if this happens upon signing, then £10,000 is released initially. There's no retention in that case, and so on. But at the next milestone, the design is approved, then the next release happens. We spoke in the past about managing state. What I do there is I use an open source approach to managing state, or a finite state machine, which would be a concept familiar to many computer scientists, around what is the current activity of the contract, what has happened in the past, is it in dispute, maybe 2 milestones have been delivered, the third one is in dispute, but that doesn't need to hold up everything else. So I use this thing called stately AI, and I represent the JCT contract, or at least a simplified version of that, using this state machine. So that's what I use to represent the state of the contract. So what effectively happens is we have the contract running in regular tech in the Accord project way of representing contracts. And then the workflows are hybrid human and AI driven workflows. So the idea here would be that humans inspect things, they use AI agents that may involve later smart cameras, drones, LiDAR sensors, whatever can feed in via robotics into an AI agent, and we manage these workflows. So once we determine that a milestone has been achieved, that will then trigger the contract. The contract will say, okay, well, that results in this amount of payment, and then that can trigger another workflow that will go and release that payment, and then update the contract to say, well, that bit of the payment has been done. So an obligation payment processing workflow, basically. This is what it looks like in Deepflow. So I guess in conclusion, we've seen AI agents really only start to become commercially viable, I think, in the last number of months, even, really. But with a huge momentum behind them at the moment. Some people claim a bubble, but that's for a different conversation. But nevertheless, we've seen them be quite capable, and now via things like MCP, able to connect to more tools in the real world. We've seen privacy preserving technologies improve. I spoke about things like trusted execution environments and selective disclosure protocols last year. So you can look back on that. So we can have an immutable record, but as I mentioned, we can then change the state of the contract in a way that you can't change an immutable smart contract. And then if there is some dispute resolution or something that wasn't envisaged in the contract or couldn't be properly codified, we can change the state of the contract and then allow it to run, all with an audit trail of what's happened and with everybody signing off on the change. So I think if we combine both the AI agent workflow with the humans and have that audit trail on chain as well, along with the smart legal contracts, then we can have this model where we have humans and machines interacting with each other, improving performance, and improving traceability, and also autonomy in the sense of interacting with the contract. So I guess the future really lies with the humans and the machines working together, and hopefully with a way of embedding these into better, more responsive contracts. So that's all I have for the moment. So we can maybe do the question and answer session towards the end of this session as planned.